What are the different join types? What's the difference between an inner join and an outer join? What is the difference between a left outer join, right outer join, full outer join? What does each of these ones mean and how do we use it? If you're curious to understand more about the different kinds of joins, then stay tuned. Hello and welcome. My name is Elhelw. In a previous video, I talked about join algorithms. We talked about nested loop join, merge join, hash join, and all this stuff. And in that video, I mentioned that I was focusing mostly on inner joins, which is the most common kind or most common type of joins that people use in their queries. But I also did mention that there are other kinds of join, but we did not talk about these in that other video. But today is going to be the day where we talk about these different kinds of join. So let's start by reviewing inner joins and seeing what that means, and then go from there to the other types. So to explain inner join, let's start with an example. Suppose that we have these two tables. We have a customers table and a stores table. The customers table has ID, name, and city where that customer exists. And the same thing for the stores. We have a store ID, store name, and city. Now, let's suppose we have a question that says, okay, find the customers and the stores that are located in the same city. So we want to answer this using the tables that we have. And this is a very basic join query. So the answer would be joining both customers and the stores on the city column. In this case, it's going to be an inner join. And just because inner join is the default, usually we can omit the word inner in our query, so we can write just a join. It's understood when you write a join, it's an inner join. The result of this query will look like this. So we're combining rows from both sides, from the customer and the store side, based on the join condition, which is the city has to be the same. So any row from the customer and any row from the store that have the same city will be combined in the output. If we look at an example, the city New York is mentioned in 2 customers and in 2 stores. So this means that we have 4 different combinations that may have New York, and these are listed here. So we have John, the customer John with store 1. We also have John with store 3. And we also have Tom with store 1 and Tom with store 3. So all the different combinations of rows that have New York. Same thing happens with Chicago. We have 1 customer with Chicago, 2 stores with Chicago. So we have 2 different combinations that we can see in the output. Now, the rows that are on the customer side or on the store side that do not have a match on the opposite table, for example, we have Bob, who is located in Los Angeles, but we don't have a store in Los Angeles. So then Bob is not part of the results. Same thing with Emily, who lives in Boston. We don't have a store in Boston, so Emily is not shown in the result because it doesn't match with any of the stores. Same thing with on the store side. We have store number 4, which is located in Miami. Since we do not have a customer in Miami, this means that this store doesn't match with anything, so it does not show up in the result as well. So the only thing that shows in the results are things that match from both sides, from both inputs. We can represent this in the following diagram. Suppose that A and B are the tables or are the inputs of the join. And we have things that appear in both tables. So this is the area in the middle. So this area represents the inner join. The inner join only produces things that appear in both tables. If something appears only in table A or in table B, then it's not part of the join result. One thing to note as well is that the inner join operation is symmetric, and we can switch the sides of the join. So if you say A inner join B, it's the same as B inner join A. This is something that the optimizer uses often when it switches the sides of the join, because let's say if it switches them, it can find a more efficient plan to do the join. Because the join is symmetric, the inner join is symmetric, the optimizer is able to do that. So this is the inner join. We've seen that before. We use that in most of our queries. So this is the most common type of join that people use. Now, let's say we want to modify the query that we had a little bit. And instead of wanting to see only the things that match on both sides, we also want to see things that maybe are not matching. For example, let's say we want to see all the customers, regardless of whether or not they match a store. How do we do that? So inner join will not allow us to do something like this. So this is what leads us to outer join. Before I talk about outer join, just wanted to say a quick note. Don't be confused between inner and outer joins, which we're talking about today. And when we talked earlier about joins, and we said that the inputs of the join, the left input and the right input, can also be called the outer input and the inner input, right? Because of the nested loop join. The naming is unfortunate, and I know it's confusing because it's the same names or the same words used in different contexts, but let's try to separate those. That was talking about the inputs of a join. We have an inner input and an outer input, which can also be called the left input and the right input. But today we're talking about types of join operations. We have an inner join operation as a whole, which is the regular kind of join, and now we're going to talk about the outer join operation. I know it's confusing, but try to separate those in your mind. Okay, so before we explain what outer join is, let's go back and see. Inner join, this is the diagram that we just saw before. So inner join represents the common things that appear in both inputs, right? So now if we want to see more than just that, then we have all these different other combinations. The first one on the top right corner basically means that we're going to show things that exist in both, plus things that exist on the left side only and do not have a match on the right side. This is called a left outer join. So left outer join means you're going to show the stuff that we've seen in the inner join, which is the common things that appear on both sides, plus things that appear on the left side only. That's why it's called a left outer join. The opposite is the right outer join, which shows also the common, the matching things on both sides, plus things that come from the right side only but do not have a match on the left side. And then the final one is the full outer join that shows the matching part plus things that come from either side and do not have a match on the other side. This will be clear once we start showing the examples. So let's start with talking about the left outer join. Here is the inner join queries that we just saw a few minutes ago. Now we want to replace that with a left outer join query. So we're going to replace the inner join in the query with left outer join. And this means it's a left outer join. So everything coming from the left side must appear in the results, whether it has a match on the right side or not. So the outputs of the inner join is going to be part of it, of course, but also things that were not part of the inner join, things that are coming from the left side, which is the customer table in this case, but did not have a match on the right side, these will also be part of the output. So these customers will also appear in the output, but because they do not have a matching store, the store portion of the output has to be filled with nulls. So null is a special value that indicates either the absence of a value or just basically meaning that we don't know what the value is or there's no value here. So this is what a null means in SQL. You will find this used in many different contexts, and sometimes it is written as the word null, sometimes it just looks like an empty space. So this is basically what's going to be in the result. For things that have a match, it's going to show both sides. For things that exist only on the customer side, because that's the left side and this is the left outer join, then it's not going to have any data in the store portion of the results. It's going to have nulls. Things that are coming from the store side but do not have a match on the customer side are still not shown. Because again, this is a left outer join. We care about showing all the stuff coming from the left side. Things that are coming from the right side and do not have a match are not going to be part of the output. And for simplicity, we can usually omit the word outer from the query. So we can just write left join, and this is understood that it's a left outer join. The opposite of that, if we want to do a right outer join, so again, we're back to the inner join query. Now we can replace that with a right outer join. And this is the opposite of the previous example. So now we care about what's on the right side of the join, which is the stores table in this case. We want all the data coming from the store side to be part of the output. If it has a match from the customer side, it's going to be with that match. If it does not have a match, it will be padded with nulls like we've seen before. So the only one that does not have a match was store number 4, the one that's located in Miami, because we don't have any customers in Miami. So this will be added to the output, and the customer portion of the output will be null. So this is what the output will look like. And again, we can omit the word outer from the query, and we can just say right join. One thing to note, when we talked about inner join, we said that the inner join is symmetric. We can say inner join between A and B is the same as inner join between B and A. This does not apply to left outer join and right outer join. So left outer join between A and B is not the same as left outer join between B and A. We cannot flip the sides of that operation. Same thing with the right outer join. Right outer join between A and B is not the same as right outer join between B and A. So we have to be careful. This is not a transformation that we can do. But we can transform from left outer join of A and B to right outer join between B and A. So if we flip the direction of the join, then we can flip the join inputs as well. Because both of those mean that we're going to get all the rows from A, whether they match with B or not. The things that are in B that do not match will not be part of the output. So the optimizer will often do this transformation, again, depending on the cost of both these plans and depending on which one will be more efficient. You might have a query that has a left outer join and then see the plan that used the right outer join, or vice versa. So that's just one thing also to keep in mind. The third type of outer join is the full outer join. So again, starting from the inner join query, we can replace this with the full outer join. Full outer join means, again, things that match will be in the output. Things that do not match from either side will be added to the output with nulls on the other side. So looking at the customers table, we have these two customers that do not have a match on the store side. So these will be added and then add nulls where the store would be. And then on the opposite, we have this store that does not have matching customers. So it will be added in the output as well with nulls in the customer part of the output. So this is what the full outer join looks like. And again, we can also omit the word outer and use just full join. Full outer join is similar to inner join in the sense that it is a symmetric operation as well. So we can flip the sides of the full outer join and it will still give us the same result. So again, the optimizer may choose to do that. For all the joins that we've seen so far, the inner and the outer joins, with its three different types, the right, the left, and the full, we can still use all the join algorithms that we've talked about before. So we can perform them using nested loop join, we can do a hash join, we can do a merge join. So any of those join algorithms can still apply for outer join and inner join, which we have already seen. So the join algorithm will still apply the same way we talked about it before, except in the case when, let's say, it does not find a match and it's a left outer join, then it will still output that row with nulls. All right, let's see together how this looks like in Postgres. So let's first look at the tables that we have. So this is the customers table, and this is the stores table. So tables, the exact same ones that we were just talking about in the slides. So first, we're going to try out the inner join, which we've seen before. So we can write just join, or we can write inner join. Both are the same thing. So here's the query. So let's start from customers join stores on, customer city equals store city. And this is the result that we get. So as we have explained, we only get the rows that have matching cities on both sides. If any row on one side does not match anything on the other side, it's not going to be part of the output. So as we can see here in the original table, we have this row, Emily and Boston. We don't have Boston in the stores, so it's not appearing in the output. And the same thing for store number 4, which is in Miami. We don't have Miami in the customer, so this does not appear in the output as well. So this is the inner join. And we can take a look at the plan here if we do explain. So we'll see that we used hash join to execute this query. Let's go to the new ones that we've talked about today. So let's start with the left outer join. So if we replace our query with a left join query, and like we said, we can write left join or we can write left outer join. Both are the same thing. So here we have left join. So customers is on the left side, stores is on the right side. So this means that anything that appears in the left side, the customers, has to be part of the output, even if it does not match anything on the store side. So let's look at the result. So we have all the customers. The ones that match are shown with the matching stores. The ones that do not match have nulls where the store will be, because obviously there is no matching store. So we have Bob Los Angeles, and there are nulls here, which is these empty cells. Same thing with Emily Boston, and we have nulls here. So this is because we did a left join. Let's look at the plan. What does the plan look like in this case? So here we have a hash left join. So like I said, we can still use all the join algorithms that we've discussed before, hash join, nested loop join, and all that, with any of the inner and outer joins. So in this case, it chose to use a hash join, but of the left join variety. So it still applies the same hash join algorithm, but it also outputs things that may not match on both sides with nulls. Okay, let's look at the next one. Let's look at the right join. So we're going to replace the left join with a right join in this case. Again, we still have the customer table on the left side, and we have the store table on the right side, and then we have a right join. Right join means that everything coming from the right side has to be part of the output, even if it doesn't match. So all the stores will be shown in the output. The ones that do not match a customer will have nulls. So this is the result. All the stores are here. And then store number 4, which did not have a match in the customer side, has nulls on the customer part of the table. So this is what we expected. And then let's look at the plan as well. This one is interesting because even though the query is a right join, the plan shows here hash left join. Like we've just explained, we said that right join and left join can be swapped. When we say A right join B, it's the same as B left join A, right? So the optimizer can swap those if it realizes that using one is more efficient than the other. So in this case, it chose to do a left join, and it swapped the tables. Instead of customer being on the left side and stores being on the right side, now we have stores on the left side and customers on the right side, and the join is reversed. So these are equivalent. It produces the same result that we would get otherwise, but it is more efficient from the optimizer's point of view. All right, let's see the next one. So the next one will be the full outer join. So full outer join means that on both sides, we need to see all the rows. The ones that are matching will be matching. The ones that do not have a match on either side will be padded with nulls. So this is what the result looks like. So customers that do not have a matching store will have nulls in the rest of the row. Stores that do not have a matching customer will also have nulls in the rest of the row. And let's look at the plan. Here we have a hash full join. So again, it's a hash join, but for the full outer join type. Okay, so all the joins that we've seen so far, both the inner and the outer, the result has data from both sides. So with the example that we've seen, customers and stores, the result always has data from both the customer and the stores table. Of course, we could restrict the results and we could project certain columns, but in general, you want to get results from both sides. There are some other operations that are also called joins, but they're not really like the standard kind of join. They're not joins in the traditional sense. They still use joins under the covers, like the system will use a join operation to implement or to execute that. But we do not write them as a join in the query. I know it doesn't make sense, so we'll just look at it as an example to see what that looks like. So the first one is called a semi-join. What is a semi-join? Starting with the same two tables that we've seen before. Suppose that the query now we change it slightly. So instead of trying to get matching customers and stores, we want to find all the customers that have a store in their city, right? So it's still matching in a way that we're still trying to match customer and stores, but we want only the customer information. We want only to see the customers that have a store in their city. So just based on the description of the query, we should be getting those 3 customers, John, Alice, and Tom, because they are the 3 that have stores in their city, in New York and Chicago. Bob, who is located in Los Angeles, does not have a store in his city, and the same thing for Emily. So the answer should be those 3. How do we write a query to get those results? One might say, okay, let's do an inner join. An inner join will match the stores and the customers, but then instead of doing select star, we could do select just customers.star. So this will project only the columns that are coming from the customer side, which is what we're looking for. We really don't want to output the store information, we just want to output the customer information. So does that give us the information that we're looking for? Let's see. So the original query, if we do select star, this is the data that we'll get, right? All the different combinations between things in New York, things in Chicago, and so on. If we do the projection, so project only the 3 columns coming from the customer side, then this is the output of the query. This is close to what we want, but it's not exactly what we want, because we have here duplicates. We have, John is duplicated twice, Alice is duplicated twice, and so on. They're duplicated because initially they are matched with different stores. So each of these customers may have multiple stores that match. So we repeat the customer for each store. But if we want to see just the list of customers that have stores in their cities, we shouldn't get these duplicates, right? So we want to get only the 3 original customers from the original table. So this is not the result that we're looking for. One might say that, okay, we can do this and then add, select distinct to remove the duplicates, which might work. For this particular example, it might actually work, but it might not always be correct. Like if the original table had some duplicates, for example, then that will also remove the duplicates from the original table, which basically would be also not completely correct. For this kind of queries, we usually use a subquery. There are multiple ways to get this answer using subqueries. So we're going to look at 2 of the popular ways. Again, under the covers, these are implemented usually as a join, which we will see in the demo later on. But let's see first, how do we write it in a query? So the first way to do this is using the in keyword. Basically, the query will look like this. So select star from customers where city in, and then you have a subquery that looks at the cities coming from the stores. So it's basically almost like you're trying to get the cities that have stores in them, and then for each customer, see if if the customer happens to be in one of those cities, then that customer is part of the result. If not, then that customer is not going to be part of the result. So this subquery basically selects city from stores. It's almost like, imagine getting a list of the cities from the stores table. And then it becomes as if it's just like a scan with a filter on the customer's table. So for each customer, first customer, John, does New York happen to be in this list? Yes, so John is part of the output. For the second customer, Bob, does Los Angeles happen to be part of this list? No, then Bob is not going to be part of the output, and so on. So the output will look like this, which is exactly what we're looking for. Under the cover, this may be, like as I said, like this will be implemented as a join. So this list might actually be a hash table. So you build the hash table on one side, and then for the other side, you're going to look up in the hash table, and you see if what you're looking for exists in the hash table, then you output it. If not, then it's not part of the output. This is basically a hash join. So this is one way to implement this, and this is called a semi-join, because it's like a join, but you're looking only at one side of it, and you're outputting only one side of it. Another way to do this, again using subqueries, instead of using the in keyword, you could use the exists keyword. So a subquery would look like this. This one is slightly more complex because it has this inner reference to customer. So this is called a correlated subquery. Basically what happens here is that for every row in the customer table, again, we're going to evaluate this for every row, right? For every row, you want to evaluate this subquery. And to evaluate the subquery, you want to substitute c.city with the city that's coming from that row that you're looking at. So when we're looking at the first row, for example, the city is New York. So it's almost like we want to evaluate this subquery, but we substitute New York for the city. So select star from stores where city equals to New York. Does this return anything? Yes, we have a couple of stores in New York, so this query will return a couple of rows, right? We don't really care about what the query is returning, but we only care whether it returns something or not, because we have this exists clause. Exists basically means that you want to see if that subquery returns a non-empty result or an empty result. If it's a non-empty result, then exists is true. If it's an empty result, then exists is false. So in this case, for New York, the subquery returns some results, so exists is true. So then this row, John and New York, is part of the output. When you go to the next row, substitute Los Angeles in the subquery. If you run this subquery, we don't have any stores in Los Angeles, so that subquery will return 0 rows. So the exists filter or the exist condition is going to be false. So this means that this customer is not going to be part of the output. So this is how this kind of correlated subquery is executed. Again, under the covers, this might be implemented as a hash table, and you're looking up things in the hash table to see whether something exists or not. So this is what the output will look like. One thing to note, because that subquery, because we don't really care about the contents of the rows, we only care about whether there are rows or not, right? So one optimization that we usually do in this case is that we replace the select star in the subquery with a constant or something, because no matter what you return, like the contents of the row doesn't matter. It only matters whether you have rows or not. So if we replace this with, let's say, 1, it will still give us the same effect. It will return some rows, or it might be an empty result, in which case, we will find out whether exists is evaluating to true or false. So using a constant here is more efficient than using select star, especially if these rows are huge. You don't want to read all the rows from disk. So in this case, you just select 1, and this will tell you if that subquery is empty or not. So usually when you see exists, you will see something like that with it. The opposite of the semi-join is the anti-join query, sometimes called the anti-semi-join and sometimes just called the anti-join. It's the same thing. Basically, it's the opposite question. It's saying that, find the customers that do not have a store in their city, right? So it's very similar to the previous one, except we use not. Like instead of using in and using exists, we're going to use not in and not exists, and the exact same syntax of the queries. This is called an anti-join. All right, let's see what this looks like. Here are the tables again. This is the customers table, and this is the stores table. Now we want to try the semi-join. Semi-join, we said we're looking for all the customers, for example, that have a matching store. We don't want to show the stores, we just want to show the customers that have some matching store in the same city. So like we said, one could think that they could do an inner join and just project the columns coming from the customer side. But if we try that, we get duplicates. So this is not what we're looking for. We're looking just for the rows from the customer table that have the store in the same city without repeating them multiple times. So this is not the way to do it. So we said that the way to do it will be using subqueries, either using in or using exists. So let's try both. So it will look something like this. So select star from customers where city in, and then select city from stores. This will give us the results that we're looking for. So the 3 rows that correspond to customers that have matching stores in the same city. So let's do an explain for this query. And there we go. We have a hash semi-join. So even though the query does not have a join in it, like we said, this internally is implemented as a join operation. In this particular case, it's a hash join. So it's a semi-join using a hash table. So again, we're building a hash table on one side and then using that hash table to see what matches and what does not match, and returning that from the customer side. Let's also try the other way of doing this using the exists subquery. So the query will look like this. Now we have where exists, and then select 1 from stores where s.city equals c.city. And we have the same result as before. And again, if we want to look at the plan, this is what the plan looks like. Again, it's a hash semi-join, the exact same plan as last time. So this is for the semi-join. If we want to try the anti-join, so basically all we need to do is add not here. So we want the customers that do not match a store in the same city. So we can just add not, and we will see that this is now a hash anti-join. And we could also run the query to see what the output looks like. So these are the 2 customers that do not have matching stores. So this is basically what the anti-join is. All right, so to summarize, today we talked about join types. We reviewed the inner join, which is the most common type of join that we've talked about before. And then we also talked about outer join. We talked about the 3 different kinds of outer join: the right outer join, the left outer join, and the full outer join. In outer join, we output not only things that match on both sides, but also things that may be on one side and do not match on the other side, depending on whether you're doing right or left or full outer join. Things that do not match usually have nulls that pad the side that is not matching. We've also talked about semi-join and anti-join, which are technically not join operations because they only output things from one side, but they are implemented as joins, and they are usually done using subqueries, whether you use in or use exists. And for anti-join, you add not to that. So these will show things on one side that have a match on the other side, but without returning the corresponding matches from that other side. I hope this video was helpful, and I hope it managed to explain and show the differences between the different types of joins. If you have any questions, please add them to the comments. Otherwise, please hit the like button, subscribe to the channel if you haven't already, and thank you so much for watching, and I will see you in the next video.